Okay, all right, everyone. So this is going to be used for the day when I'm not here. So I would like to use this period while you're on your own with your classmates and your substitute teacher to review this in the form of a video. I think that's good. Okay, and I want to, get a chance to save this so that people in the future can use this, should they want to. All right. So now let's take a look. So this is a review of Unit 1 where we talked about similar figures and scale drawings, or at least what we've done so far. So the first question is, what is similarity? In this video, we're going to talk about scale factor. How do you determine if two triangles, for instance, are similar? If the two figures are similar, would you be able to find the missing side? That was the quiz, right? And using scales on maps. Okay, so let's talk very quickly, okay? My favorite topic, soccer jerseys. Now, why am I showing you this? Well, if you look at the child on the left, all right, and I don't know, like the college student on the right, you will realize that they're wearing the same jersey, right? Which is like straight up fire. I've been wanting this jersey for a while. Just don't know how the sizing is. But speaking of sizing, right, when we look at these two jerseys, do you consider these jerseys to be similar, right? And what do we mean by similar? Well, one is they have the same shape, right? So like you don't look at this jersey and think that like it has nothing to do with this, right? It's the same design, same company, just different sizes, right? So this one I don't even know, probably like that's what a 7-year-old wears, right? So this is the 7-year-old version of the Japanese jersey, right? And this is like the adult version, right? This is probably like an adult size medium, right? Of the same jersey. So same shape, different size, right? So that's what we're talking about here, all right? And so now, moving on, we're not going to talk about jerseys all day, but so few things we notice about similarity. So here on the left side, we have a triangle. Let's call that triangle ABC, all right? So I'll highlight that as I talk. So this is triangle ABC on the left side here. And on the right side, oops, that's a little off. And on the right side, we have triangle PQR, right? Now, do you remember what this symbol means in the middle, the squiggly line? What does this symbol mean in the middle? Yeah, similar, right? So this is how mathematicians speak to each other about similarity. Okay, so these two are similar, so what do we notice about them, right? Like the soccer jersey, they're the same shape, right? Same shape. ABC has the same shape as QPR. The angle stays the same, so you know how this is one arc, and this stays the same as one arc? This one has two arcs, which matches, right? Corresponds to the one on the right. And finally, angle C here has the three arches, which matches the one with three arches. Which is also to indicate that angle A is not the same, has a different measurement than angle B, than angle C. Okay, so this is a triangle where all three angles are different, for instance, right? And so these angles are matching, right? A with P, I'll use a different color. A with P, they're matching, and meaning they're the same measurement, right? Angles stay the same angle measurement in degrees. Angle B and Q, they match, they're the same angle, so they stay the same. And C and R, they're the same angles. Also notice the way this is written. Have you noticed? A matches up with P, B matches up with Q, and lastly, C here matches up with R, like that, right? So the order actually even matches. Okay, and the last thing is they share the same scale factor, right? So whatever multiplied by this side here whatever you multiply with the scale factor, all three of them are gonna share the same scale factor, right? By multiplying them, right? You can't add or subtract, remember? Okay, so that's the first thing. Now, let's talk scale factor then, right? What's a scale factor? Well, there are two ways you could scale a figure, right? You can make it larger, like this. In which, what do you think the scale factor is gonna be in general? Yeah, it's gonna be greater than 1, right? Because you have to make something larger, right? So it has to be more than 1. Could be 1.1 times bigger, it'll be a little bit bigger, right? Could be 10 times bigger, right? And on the other hand, you have a scaled down figure, which means they got smaller, right? So what do you think the scale factor generally will be? Yeah, less than 1. So let me ask you one more question. What if the scale factor is exactly 1? What do you think would happen to the shapes? Yeah, it will stay the same, okay? All right, moving on. So here I got 2 examples for you. So let's do the first one. Let me show you the first one, and I'll let you try the other 2, all right? Now, here we have a scale factor that went from 10 to 20, 6 to 12, 8 to 16. So therefore, as I stated up here, the scale factor is 2, right? So everything got doubled. Now, there's another way you can look at it. You could take the second shape, divide it by the first side, like this, or take the 12 and put it over the 6, or put the 16 over the 8. What do you think they all reduce to? Yeah, 2 over 1, right? You see that? So the scale factor, therefore, is 2. Having said that, take a look at this one then, on the left side, all right? So take a moment, if you want, pause the video and answer these 2 questions right now, okay? So pause right now. Okay, all right, and we're back. So what's the scale factor from 3 to 6 and from 8 to 16? What do you have to multiply by? Yeah, 2, right? So 8 to 16 times 2, right? So the scale factor must be 2. Now, again, you can look at it like this. 16 over 8, 6 over 3, right? What do they both reduce to? Yeah, 2 over 1, right? So the scale factor is 2. Okay, how about this side? Now, this is slightly interesting. Here's why. They gave you the 40, I'll change colors. They gave you the 40, which matches up with the 48. That's a 48. Let me move this so you can see a little better. All right. So if I move this down here, is that better? Yeah, that's better. All right. Right, so these matches. So we went from 40 to 48. Now, here's the tricky part. The 24 is up here, the 20 is down here, so you can't compare them. Okay, so what's the scale factor? We can only look at from 40 to 48. Now, it's not going to be a whole number. You already realize that. So we're going to use the method that we've just done. We're going to take 48 over 40, and what does that reduce to? Okay, let's see. So let's see. 8 going to 48 6 times. 8 going to 45, so it's 6 over 5, or 1 1/5. That's the scale factor. Okay, you got that? All right, let's move on. If you don't understand this, you can rewind and rewatch it, by the way. Okay, it's no problem. Okay, how do you determine if 2 polygons are similar? Okay, so here we got the 2 shapes here. All right, so triangle ABC, this one on the left is similar to the one on the right. Okay, so now we're start looking at this, right? Are they similar? So remember on the quiz, how did you find out, right? You have to compare these ratios. So okay, so let's do 15. So again, left to right. So let's do 15 to 10. We could do 12 to 8. We could go 9 to 6. Now, if you were to reduce this, would all of these have the same scale factor, right? Well, let's see. What number goes in both 15 and 10 when you reduce it? 3, right? And goes into 10 twice, right? It's 5, right? 5 going to 15 3 times, 5 going to 10 twice. What about 12 and 8? What number goes into both 12 and 8? Yeah, 4, right? 4 going to 12 how many times? 3, and then 4 going to 8 how many times? 2, right? And how about 9 and 6? What number goes into both 9 and 6? 3 and 2, right? So they're both 3 over 2. So are these two polygons similar? Yes, Queen, you bet. All right, so these figures are similar because they all reduce to the same ratio, meaning also they share the same scale factor. Meaning, if you take 8 and you multiply it by 3 over 2, you get 12. If you take 6 and you multiply by 3 over 2, you get 9. If you take 10 and you multiply by 3 over 2, you get 15. Is that clear now? Okay? All right. Now, why don't you, no, I don't have an example for you, actually. So let's move on. Okay, so second to last topic. How do you find the missing sides of similar figures? Okay, so here you got MNP and STW, right? On the left and on the right. Now, they are similar. They told you they're similar. Okay, so let's find the missing side. Where is the missing side of the similar figures? Well, we got two things here. One, we got a missing side here, so I'll label that as X. By the way, feel free to take notes too, like, all right? This is labeled, as a missing side here, so I'm gonna label that Y. So far, so good? So I'm gonna, let's see. The only information I know for sure is here. The 20 and the 15, because they match, right? Their corresponding sides. So, okay, let's match them. So how about 15 to 20 is 24 over what? Right? So again, left to right, right to left, right? 15 to 20, 15 to 20 is 24 to what? So now I'm gonna grab my calculator. You should have your calculator in front of you also. So let's see, 20 times 24 is 480. And then divide that by 15. 32. All right, so this is 32. X is 32, okay? Now we gotta find Y, so I'm gonna use a different color. Let's use purple. We could do the same thing. We could do 15 to 20. Is 15 to 20 is Y to 36, right? Because I'm going from right to left, right? Smaller triangle to bigger triangle. So again, cross multiply, 15 times 36, 540. Divide that by 20. It's 27. So this is 27. Okay, that's how you do this. So I think I got one example for you here. Now, I picked this question for a very specific purpose. And that's because these two, have you noticed, they have different orientation. Now, we mentioned this in class. What do I mean by that when I say something at different orientation? Two shapes at different orientation. Yeah, they're not facing the same way. So right now, not that you've not done it before, right now, press pause in your notebook, redraw this triangle here, REV, so that it looks like the way that DKL is sitting. And then you label the sides and find out what the missing side is. Okay, so press pause right now. Okay, and we're back. So here's what we're gonna do. So I'm gonna draw, so what I'm gonna do is inside the large triangle, I'm gonna draw a smaller version. In other words, I'm gonna draw REV inside here. So I'm gonna go like this, and like this. And I'm gonna label the angles. So E is that obtuse angle, right? So this is E. And I know if that's E, this must be R, right? Because I'm rotating this shape like this. All right, as a matter of fact, I'm gonna do this right now. I'm gonna take a picture of this shape here. Let's see if I can do a good job of it. Let's see, hold on 1 second. All right, can I do that? Can I do that in a video? I don't even know. Okay, maybe not. Okay, I guess not. Okay, I can't do that in the video, so I'm gonna have to like, hand draw it. That's all right. So here, rotate, right, that's E. R is now here, so this one must be V, okay? RE is 44. RE is 44. EV is 60. So we have to find out the missing side here and here. All right, so let's try it. Okay, so let me use a different color. So now let's see. I'm looking at this one here. Actually, I can use this one, right? So if we go big to little, 75 to 44. In outside to inside, I could go outside to inside. 105. Let's call this X, okay? A little more professional. 105 to X. Let's solve for it. So everyone, if you haven't done it, go ahead, take a calculator and follow me. 44 times 105, it's 4620 divided by 75, 61.6. So this is 61.6. And then down here, I'm gonna do the same thing. I'm gonna do 75 to 44. If I'm going too fast, you can also slow down the video, okay? 75 to 44, and then Y over 60, right? Again, outside, outside, in, outside, in. All right, 75 times 60, 4,500 divided by 44, that's gonna be a decimal. Okay, it's 102.27 repeating. That's some crazy number there. Okay, all right, last thing. We're almost there. Last thing, oh, word problems. Okay, let's do a word problem then. I saved this question for the video, all right? So, Lance the alien is 5 feet tall. This is Lance, say, everyone say hi to Lance. All right, his shadow is 8 feet long, and we got a tree. The shadow is 32 feet long. So what's the height of the tree? All right, do you guys hear the ice cream truck? All right, that's funny. Okay, all right, so let's set up the proportion, right? We can do 5 to 8 is equal to X to 32. Again, you can try this on your own if you want to. Or you can go like this. You can go 5 to X, 8 to 32. It's up to you. Okay, so here we went alien to his shadow, and then tree to his shadow. Or you could go alien to tree, shadow to shadow. Okay, either way, so let me just solve it like this. 5 times 32 is 160. 8 times x, so divided by 2, divided by 8, my bad, is 20. So the tree is 20 feet tall. All right, I think we got one last thing here. All right, okay, so this is the last topic before the end of the unit, which is how to use scales on maps. So if you look at any maps, right? So in this case, it's like the map of Japan. You see this here. That's a scale. All right, we must have talked about this briefly in class already. It just tells you, hey, you know, if you see a distance from this to this, right, how long is it in real life? Okay, so the distance between Troy City and Bend City is 315 miles. How far apart? By the way, this is given. Okay, they have to give you this. So, okay, what are we comparing here, right? You remember setting up proportions? We're comparing inches to miles. Right, so 2 inches on a map would be 35 miles. So if the real distance is 315 miles, how long is it in inches on the map? Okay, these all sound very familiar by now, right? So 2 times 315 is 630. And then divide that by 35. what would that be? 18. So on the map itself, they will be 18 what apart? Inches or miles? Yeah, inches, right? Because the map is not going to be 18 miles long, so it has to be inches. All right, is there a question for you here? Okay, one last question. Try this one on your own. So press pause right now. Okay, and we're back. So a typical scale for a house plan is 1 inch to quarter inch to 1 foot. So I'm gonna set it up immediately. Inch to foot, quarter inch, 1 foot, right? If it measures, if the width on the plan itself, the map, right, is 3.5 inches, what's the actual width? Now, I purposely picked fractions. Whether you choose to turn these fractions into decimals, that's up to you, but I'm gonna stick with fractions just to do as a review, right? So we're gonna multiply these, 3.5 times 1 is 3.5, right? And then we're gonna divide it by a quarter. So it's 3.5 divided by 1/4, right? Remember how to divide fractions, right? You gotta turn this into a mixed number. 2 times 3 is 6, plus 1 is 7. Keep, change, flip. Right, we can cross cancel. 2 going to 2 once, 2 going to 4 twice. 7 times 2 is 14. What does that sound? All right, that's 14, 14 what? 14 feet. Right, because we're looking for feet, right? Feet, looking for feet, so it's 14 feet. Okay, all right, I think that's it. Yeah, that's it, I'm done. I have nothing more to say. All right, it was long, but you guys had a whole period, so I figure it's a good way to review while I'm not in school. So thanks for having the patience to watch this. If you took notes, kudos to you, all right? I might check notes tomorrow, and if you take good notes, I might even give you some extra credit. So let's see, okay? Let's see how this goes. All right, thanks for watching. Have a good day. All right, I'll see you back in school on Friday tomorrow. All right, bye now.
OMG, that was so good.